Huh?
The relevant part of the tutorial for us.
Yeah. But now we're going to do completely irrelevant stuff for the engineers. So let's bring up Rhino. It's going to be useful. Hey Eddie, how much sleep did you get? Okay, enough? Okay. What? What did you get, Eddie? You got banana bread. That's why you're falling asleep. You know bananas make you sleepy.
I had 12 hours sleep and I'm still sleeping.
I hear you, man. I hear you. Good fuck. Okay. Okay, so if you remember the lecture, we were talking about shape topography. Do you want me to just talk about the word topography for a moment? No. Topology. Shape topology. What's topography?
Topography is like the land and shit.
Yeah. It's the shape of the land, right? What's topology?
I'll look it up.
Huh? No. No, the key part of topography is the graph. Graph makes it land, not the topo.
It's like a triangle.
That's topography.
Yeah. No, topology.
Topology is a triangle.
Yeah. It's like the system.
Yes. Yes, the triangle's the wrong word.
Yeah, triangle's like a very stupid, simple.
Yes. Hang on. My camera can be on. Maybe I should just run this all with Rhino. No whiteboard markers. Let's just see how that goes. Okay. So. Yeah. Yeah, I will share the screen. Hello. Okay, I'm going to throw out some typologies that have universal topographies, and let's just talk about them. So, how can we describe a point in space?
Coordinates.
Yeah. What are the coordinates? X, Y, and Z, right? That is a topology. Every point shares the same structure, and so therefore you can compare 2 points by looking at their topology. So coordinates, points can be other than X, Y, Z. They can be other types of topologies, but simply put, they share the same. They're all the same type, and in a way, you can say topology and typography in software engineering, and they mean the same thing. Okay, but if we look at other topographies that you guys are aware of, what about surfaces? What does every surface share with every other surface? NURBS surface in Rhino.
4 points.
Yeah, can we, rather than 4 points, what can we say? No, ignore the corners, it's the other thing. Yeah, 4 sides. Every surface in Rhino is 4-sided. Even surfaces that look like this, that's a 4-sided surface, right? Where's the 4th side?
It's a.
Can we say it's zero?
Pardon?
Can we say it's 0 parameter? What the last one?
The last side.
The last side's up here.
Can we say that it's 0?
It's 0. It's infinitely small, right? I heard a person at Rhino call this a singularity. So whenever a surface comes to a point where one of its sides is infinitely small or infinitesimally small or 0 length, they call that a singularity. That's their official term for it. So this is 4-sided. So as you look at these, you can see this cross that goes over these two surfaces. You can see that cross sort of runs at 50% along that zero length. So 50% of zero is 0. And then it's at 50% along that length, right? What that means is you can map I remember apply surface mapping, select target objects, mapping channel for surface. I can't remember it, but basically, these two circles on those surfaces are in the same place based on the surface's topology. So we can assume things about like we can make very good assumptions about what surfaces are going to do because of their topology. Now, you guys have played around, like you know what a mesh is? I'm asking you guys. You know what a mesh is? How do you describe a mesh? What is a mesh? It's not a surface. Huh?
Would it be like a collection of points that allow it to?
Yeah, it's a collection of points. Or I like to use the word cloud. It's a cloud of points, but what else? Yeah? What do lines do? What are lines doing? Huh? No. What are the lines doing? Yes. And they connect the points to create what? No.
Triangle.
Yeah, which we could also translate into the word face. That's an important word with meshes, okay? So meshes are a collection or a cloud of points with instructions on how those points are connected to create faces in that geometry. And every 3D movie that you watch or 3D animation is using meshes. And what happens is, video game and all of that stuff and everything that we see in 3D on this computer is a mesh. The critical thing there is we can use mesh topology to animate meshes, right? So if you imagine I've got all these points on my face. Let's pretend I'm a CG character and I've got all these points on my face. If I move one of the points, as long as that point is connected to the other points around it using the same topology, then it will look like my cheek is moving or my lips are moving. And that's what animators do. They basically take a 3D model, a base 3D model of a character. So let's go Toy Story rig. They take a base 3D character and then they move the vertices that describe that character to other positions. And a key one is like facial expressions. So they take this model, then they move the vertices to let's say a p sound, p, and then they say, hey, let's turn up the p on that character's face, and the vertices move into that position. And because it's the same topology, it looks like it's actually animating, right? So topology is all about how things are connected to other things within that same system. And if those same things are the same structure, then we can say that something has the same topology. That also applies in graph theory. So if you look at your family, does anyone here have a brother or sister, a mother and a father? You have your family, where you sit in your family is the same topology as me. I have a brother or a sister. a father and a mother. And so those are the same. And if we start to say, okay, well, the gender matters, so you have to have a mother and a father and a sister. Does anyone have that? Right, but you're not male, so we don't have the same topology, right? Now, so people can look at, like, if you, let's say you use Facebook, and you don't tell Facebook anything about who you are. All you do is you're using it to be friends with other people, so you can talk to them, but you don't want to give away any information to Facebook. Well, guess what? Your friends are giving away information to Facebook, because even though Facebook doesn't know anything about you, that Facebook can look at other people with your topology. With friends, they can look at your friends and what your friends are doing, and then look at other people in the world that have the same friendship relationships with the same interests as you, and then make assumptions about you. Okay, so that's how they do. They're using topology maths. Now, we are going to start making or assessing the topology of closed polygons to work out what they are. So we're creating a shape topology, and what we want to do is make that shape topology detect whether or not this is a rectangle, that's a T, or this is a U. What else were we going to do? Huh? No, we weren't going to do E. C. No, that's that. L. That's it.
But they're not like in a straight line now.
Whatever. So picky.
You're the best.
You're welcome. Yeah, check this out. Whoop. 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 Psh. Done. Huh? You can't keep up? Well, now you know how to do that. Pardon? Yeah. Oh, how do I do that again? Did I do it too quick? It's called curve Boolean. Okay. Have you guys been taught about Booleans? Like Boolean functions? Like cutting objects away from other objects and adding them and... Okay.
We'll figure it out eventually.
Okay. So let's start building the Grasshopper script that detects this, because once we've done that, then it is up to you guys. Grasshopper. Does everyone have Grasshopper now? This is not going to benefit you.
I have grasshopper.
This is not going to benefit you, but do you think it would be worth me purchasing educational licenses to then hand out to my students for the period that you do this course?
I've already bought one.
Huh? I know you've bought it, but do you think it's worthwhile for future students? Okay.
They have to buy it themselves.
Okay. I won't buy it then.
I don't know. You
We're all in this together. Get rid of it.
Fuck 'em.
it's sort of useful to buy it.
To own it. Yeah, definitely.
We can work on it outside of uni.
You also get to use it as a commercial license when you leave the uni.
So I think it's like a good practice to buy it, but I don't know if people can always afford it.
Okay. Yeah. So we're going to do some pseudocode first. Let's actually not write some Grasshopper. Okay. Do you remember what we were going to measure to work out what these shapes are? Yeah, but what's another way of describing that?
Concave
And yeah, concave and convex. Okay. So what we're going to do is we're going to start to break these shapes down into lines, but even more importantly is we want to break them down into vectors.
Can you do the same thing on a compass instead of using just a compass instead?
What do you mean?
Like this is a south turn, this is a
No. No. As in, if I put these in order, you mean like around a center point and sort them? No. No. Also, just be careful with that in the future because you could have a shape that does this. Oh no, my battery's going to run out. I better plug it in. Like if you have a shape that does this. What? These will come before these two, right? If I have a center point and I'm sorting by the angle, then it'll do this. Yeah.
You not have it so it just moves clockwise around the.
It is. It is moving clockwise. That's clockwise. That shape's the clockwise shape of those points. From off that point. Yep. Yeah, I get what you're saying.
Yeah.
Don't let Sailor distract you. Yeah.
How is it going to order the points that way?
But we can't do it that way. It's a good thought process, especially for shapes like this. But not even just for shapes like this. But the instant you want to start doing polar coordinates, so that's what you're saying. Like you've got a point that you're checking rotation.
Can't you just check the rotation respective to the point that you're?
Yep, that's what we're about to do. You're thinking exactly the right way. Okay, so if we turn these into lines, we can also turn them into vectors, right? So there is a vector at the end of this line, and there is a vector at the start of this one. Now let's see what can we actually do with vectors. There's in here they've got a bunch of vectors, vector functions, and we can check what the angle of a vector is. So what we're going to do is we're going to step around our object. At each corner, we're going to compare the vector of the end point, the end tangent, and the vector of the start tangent, and so on and so forth around our object. And we are then going to try and compare that with, like, check its angle and then convert that angle to either being convex or concave.
That's all right.
You're welcome. We'll make it that way, man. There's enough of us use it, it'll be that. That's how language works. So, what do we have to do? We have to break our polylines down into line segments. We have to go get the start and end tangent of those lines. So we can use you guys, does this not have where is bifocals? It's like it's been uninstalled. I'll try to get bifocals on this. Should I do it now? Yeah. Oops. That was the wrong thing. Right. Apparently there's another one. Shall I try the other one? I think it's called sunglasses. Pardon? What? Yeah, I'm going to install sunglasses because apparently it's better. See.
What was the second one called? Huh? What was the second one called? You click. What was the second one you had? Yeah, that was
Sounds like Patrick's getting caught up on. Okay, let's go get those names. By the way, how's the course with Leo going? He wanted me to like combine our courses for the final assignment, and I was like, I haven't even responded to him. I'm like, no. Huh?
Bro, we are working on something weird.
Ubiquitous cities? Not the structure.
Studio 4. Yeah, we're playing with data.
Yeah, that's what we're doing here.
Studio 4.
Yeah, but you guys are expected to make a website at the end of this, at the end of Leo's, I think. If I'm gonna do it, he's not. Whatever. The problem is if he expects me to teach you something that he's going to use, I might not teach it properly. And as well, like if it require, like you need an output from an assignment. What if you fail that assignment in this class, right? That means you failed his assignment. That's not fair. So, yeah.
How did you do the thing where you turn
Ooh. How do I turn this off?
That's great.
Yeah. Oh, there it is, sunglasses. Yeah, there we go. Okay. Whoop. So is that good? That helps. Apparently, you can also do this with it.
What exactly is this called? Shades?
It's called sunglasses. In the components folder. You have to unblock it. Right click it, go to properties, and then unblock. That's something else you have to do. Okay. So we're going to evaluate our curves. Now, if we want to evaluate the start of the curve, I don't need to tell you guys what number to use, but I will. It is 0. And that is, we're going to make sure that that's running on percentages, so we're going to reparameterize. And then we also have to go get the end tangent of our curves, so we're going to run that through another evaluate curve with the parameter 1.
Why do you have to change its properties?
You talking? Hang on, guys. You don't need to do you need to install sunglasses? It's okay. Then yeah, you need to do this. If you want to install sunglasses, you put it in this folder. You right click it. You hit properties. You make sure that it's not blocked. There's a little button here that will say unblocked. Click that and then hit OK. That's just to protect you from hackers putting hackery things in their Grasshopper plugins. It's not that thing. The block thing is protecting you from it, and what you're doing is going and turning off that protection. I want to sit here. I feel like, but am I going to be in the way if I sit down here?
Probably. Andrew,
Yeah.
drink normal Coke. Why are you drinking Coke Zero?
Because I want to scar my liver instead of get diabetes. You know.
That's what I'm doing.
Declan chooses diabetes.
Yeah, I chose diabetes.
I'm choosing scarred liver. I don't drink alcohol, so might as well do some damage to it. Huh? What? You don't drink alcohol? Weirdo. I actually have found that a lot of people your age aren't drinking that much alcohol. Yeah.
I only drink when I want to get
Come to
blasted. I
my
don't drink
workplace,
for
but
pleasure.
not alcoholic.
Is it?
Yeah.
Is it a? What does that mean?
Everything is like substituted. Like we got non-alcoholic wines. And
Oh, as in it is a place for teetotalers.
Yeah.
It's a bar for teetotalers.
Yeah, Picola, it's a brand.
Pardon?
It's a brand. It's well known.
Oh, it's just a. That's what. It's just a funny name to call someone who doesn't drink alcohol.
Well,
But what's it? But I'm not someone who used to drink alcohol, so I don't really care if I drink something that tastes like wine.
right.
S-
That point
I
just
thought
had grape
like
juice.
sweet or something.
Yeah, no, I've never drunk alcohol. Although I am getting to the age where when someone asks me, "Oh, why don't you drink alcohol?" I can be like, "I used to be an alcoholic,
Oh.
but I didn't because beforehand, you get like, so you don't drink alcohol, and people are like, people's like, what's wrong with you?" Yeah, and then they go, "Why? Why don't you drink? Why don't you drink alcohol?"
It is the biggest pain in the ass when you say, why aren't you drinking something?
Yeah, I've heard the Australians don't trust people who don't drink.
Yes, I've had experience with that.
I just to tell you a funny story. So it's not just Australia that has a problem with alcohol. I think it's actually the most of the world, unless like a country's religion says that they can't drink it, or their government says that they can't drink it. Then most cultures have a really strong relationship with alcohol. It doesn't matter who you are. Like you pick anywhere in the world, and someone's getting drunk somewhere. So I used to. My ex-girlfriend is Polish, and we traveled. She's not dead or anything. She is Polish. And we traveled to Poland together to stay with her grandmother in this tiny little Polish town for about a month. And her family there, so her cousins and whatnot, were like drinking vodka like it was water.
That's funny.
And they're like, they didn't have a word for teetotaler. Their word for teetotaler is abstinent, which also means you don't have sex and you don't eat meat. Like that's just big overarching word. They're like, why are you going out with this abstinent person? Like, the abstinent people, usually are like in a religious cult or something like that. And so yes, look at me. And so every day they would try and get me to drink alcohol try and drink vodka, and I'm like, if I started drinking alcohol, I'm not starting on vodka. I know 16-year-old girls do that,
I did that.
but yep, I'm not starting with vodka. And it was plum. And they also had plum vodka, which I think was plum wine with their moonshine, because I was in the country, so they're brewing this stuff, fermenting it. So there's this interesting thing in Western Europe, which is not Western Europe, sorry, Eastern Europe, which is that, and this is probably what protects them from problematic alcoholism, even though they drink vodka like it's water, is that you can't pour your own drink of vodka or alcohol. You can never pour your own drink. That's the culture. So you always have to drink with someone else. And what happens is you pour the alcohol for the other person and you hand the bottle to them and they pour it for you. So, and then they would never pour me a drink of soda or water. They'd give me a bottle and be like, there you go. So one day I get offered a lemonade. And I'm like, I'm not drinking that. That's got vodka in it. They're like, how the fuck did you know? I'm like, you've never poured me a single fucking drink ever. And then suddenly you guys stop harassing me about what I'm drinking and offer me a lemonade. Fuck off. Like, no. So Sailor, you work in a teetotaler bar.
I'm in the warehouse, so
Okay.
there's a bottle shop, it's a bar.
Okay. So you work in the warehouse of a company that makes non-alcoholic drinks. Okay, cool.
Just make Coke.
Yeah, no, some alcoholics have ruined their taste buds, and then they get off the alcohol, and they're like, "But I still need that hopsy, bubbly, bitter beer taste," and that's why they go to that. Okay, where are we? Where were we? So, guys, we've got two tangents, and we want to measure the angle between those two tangents. We've got these two lists, but there's a problem. That is a big problem. Rebecca, what's our problem? If I measure the difference between these, what am I going to get? Yeah, they're the same, right? Because we're measuring the tangent of two lines, and we are measuring the tangent of the start of the line versus the end of the line. What we have to do is measure the tangent of the next line. So we need to shift our list for one of these so that it measures the next tangent. So let's go grab shift list. We want to make sure that wrap is set to true, which it is, and its shift value is set to 1. Now we can go measure the vectors. And I really hope this does what I want it to do, because you guys are going to be like, what the fuck? Doop. Oh. Do you guys get the same thing as me? You're not following along with this, are you? Okay, good. Oh, actually, maybe not. If you were following along, I'd be like, cool. Exactly. That's why I would say cool. Okay, so what does this mean? This is why we've got Martin. What does that mean, Martin? No, what is it? What's the whole thing saying? It's 0.5 times pi. So what is that? Yeah, it's in radians. It also means 90 degrees, right? I thought you'd know this. Yeah, it's a right angle. Maybe I should have said Ding Wen instead of Martin. No. I'm just teasing. Martin's a clever guy.
Yeah.
How do I have 3 branches? Look, Grasshopper's quite generous with creating branch structures, even though it doesn't need it. So what just happens is it makes that it doesn't. This means nothing. You can simplify that. Oh, doesn't even simplify. Sometimes this bugs out, and I really hope this isn't sunglasses fucking this up.
We only have two branches.
That's fine. This doesn't matter. This doesn't matter.
One angle.
It doesn't matter. You need to explode it, mate.
Didn't. No.
Can I change the font?
Yeah. That makes sense. I totally remember to do that.
Ooh. Cool. Now it looks nice.
Good.
Haha. Cool.
Oh, because I used it wrong.
Okay, but look, this is not helping us that much. So we can actually turn this to be represented as as numbers rather than special. So I believe if you go, pardon, this one, this one,
The integers.
0 and 1. Guys, so in the Grasshopper settings, you can go turn off. You can go turn off special case pi. Should make a pie shop called that. Special case pi. And what we're going to do is get these in radians. So if we want to just see these as degrees, we can go use the degrees function. And that's going to give us 90. Right. Now I'm running this on the L. So there is a problem. Is that a question? You went like this.
Negative. Oh.
Yeah, there's no way, it's not actually telling us whether or not it's convex or concave, right? It's just saying it's 90. See, look, that's 90 degrees. That's technically 90 degrees. Like, it's not telling us if it's turning right or left, right? It's only telling us the angle between. And so what's happening is this component, it is automatically generating a plane to measure on. And do you guys ever learn about like left hand or right hand rules, like with physics? Right. Is it left hand? It depends on what you're talking about.
It's either generator and motor.
Pardon?
It's generator and motor.
Okay. Well, in this case, with the right hand rule, you can think of, like, if you do this weird funny thing, like Buddhist type thing, I don't know, then your thumb points out in the X direction, your index finger points out in the Y, and then you're, giving the finger to Z, right?
X is across, Y is up, and Z is.
Yeah, you can do it. You can do, you can work it out, right? Yeah. What's happening here is it's taking the first angle and it's taking the second angle and it's using the first as the angle to generate the X direction of the plane to measure on, and then it's taking the second one and using that to define the Y. Even though the second one might not be pointing exactly at Y is going to be in that general vicinity of angle. And so that means if we look at this, if my X is pointing that way and my Y is pointing that way, so, like my right hand, then our Z is going to always be pointing up. But so that's a that's a right-handed corner, right? But if we do a left-handed corner like this, look what happens. My Z is now pointing down. But it still means that the angle between them on that plane is 90 degrees. So we need to force this system to not generate that plane, that flips. And the way to do that is with that last input, P. If you put into this a XY plane that doesn't flip, it's just a fixed XY plane, then we will get a what's it called again? An angle. That's not what I forgot. I was like, what's the opposite of reflex? Huh? Yeah, you'll get your defense angle. It will change. So you can see that we've now got that 270. No, it's not that. Then it's not obtuse or acute. It can't be. So is that the opposite? What's the opposite of What's the opposite of reflex angle? Deflex?
I think it's not obtuse. Because reflex is more than 180, right? So if it's less than 180, that's obtuse. Like between 90 and 180.
No, because you can have a non-reflex angle that is obtuse. Ah. Oh no, but I want to know the opposite of reflex. Huh?
Conscious.
No, that's
No, that's what Oxford says, sir.
yes. Filtered through Declan's brain. Yes. Angle reflex. Oh, maybe the opposite of angle of reflex is angle.
Reflex isn't. It has to be less than 180. It's either acute or obtuse.
It can yeah, look, it doesn't matter. I'm just talking about the word. The key thing here is that once we add that plane, the angle, not the reflex angle, the angle, one of them changes. It changes from 90 to 270. Cool? Okay.
Which shape is that for?
Pardon?
Which shape is that for?
That is for the L.
Ah.
So look, if I go grab the T,
Yeah.
we're going to either get. Yeah, I know why this is different. We're going to talk about it in a sec, okay? Okay, guys, I'm going to throw you a curveball. Maybe we'll throw that curveball in a. No, we'll do the curveball in a second. Okay, so I've got my L shape, and we're getting 90, 90, 270, 90, 90, 90, right? So 90 is going to either mean convex or concave. A nice little thing that we can do is we can subtract 180 from this number. So let's do that. What that's going to do is it's going to push our 90s. Is it 180? Yeah. Yeah, it's going to push our 90s into being negative 90s, and our positive 270s are going to become positive 90s. So what we don't want to do is we don't want to convert this into saying convex, concave, convex, concave. What would be much simpler, especially like when you have the two states, convex and concave, because there's no such thing other than in between, but we're never going to measure the midpoint of convex and concave. There's only those two states. We can convert them to Boolean numbers, Boolean figures. So we can turn negative 90s into zeros and positive 90s into ones. It's a really easy, it makes the process in the future much easier. So the way that we can do that is just testing whether or not x is greater than 0. That gives us a list of falses and trues. This is the lesson where I make the Chinese joke. I'll do the Chinese joke in a bit. Does anyone know Chinese? Yeah, you know Chinese? Yeah, Ding. Yeah. Do you know Dingwen? Do you know Chinese?
It's actually incorrect to say it's Chinese. It's Mandarin.
Oh, sorry. Dingwen, do you know Mandarin? Good. Yeah, I know. I know some people that are local born that don't know a language. there are people that grow up in certain countries that don't learn the language that they're of the country they're in.
Oh, I thought you said they don't learn a language.
Oh.
And that would be very.
There are children that are abused that happens to as well.
By the time
I don't know them. I don't know. True.
What if it's verbal or non-verbal?
Welcome to my class. Do engineering classes run like this? No. That'd be like, what the fuck? Shut up, right? Yeah. This is not one of those classes. We can muck around. Thank God. You're happy? Oh, you can actually relax? What the fuck are you doing sitting on the floor? Get a chair. Now, I do not want my convex corners to be false. I want them to be true. So we're gonna flip this. And what we want to do is and the only reason I'm doing this, by the way, is to set up a joke. Okay?
I approve this.
Good. You're not going to understand the joke.
Well,
Huh? Yes. I'm warning you, it's a dad joke. So what we get, what we want to do is we want to turn our booleans into numbers. Everyone knows the difference between, the conversion between boolean and numbers. Everyone here, just for you guys, boolean is a mathematics and computer science term. It means true and false. And I'm using English there to say true and false. There are other ways to say true and false. You can say true and false by using false as 0 and true as 1. Yep, exactly. And the funny thing is, what we actually do, and this makes it really nice, is any number that isn't 0 is technically true. But if you ever convert a Boolean back to numbers, it's always going to convert back to 0 and 1. So if I take these numbers and I throw them into a Boolean function, then there we go, true, 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 false, true. So the only one, even if it's negative, it's as long as it's not 0, it's false. Now the reason that we're going to do this is that we're now going to turn this list of integers into a string, a single string, which is going to be our shape topology. Cool? So we're going to join this. We're doing a text join that'll immediately convert all of our integers into text. And we end up with a bunch of dogs split up with a 0. So 1, 1, 0, 1, 1, 1. I know I sound like a dog, but there you go. You got it. There's the Chinese joke.
What do dogs bark? 1, 1.
In China and Japan, dogs say 1, 1.
Yeah, so yeah, I get it.
Wait, can I ask a question before we keep moving?
I make that joke about my apartment because my apartment number is 1111. I go, and if I say that to any Asian person, I say, sorry to sound like a dog. And they're like, you are such a daggy fuck. Go. Yep. Yeah.
Just my numbers in the first panel on the left. Yeah, those ones. Sorry, on the right.
The big panel at the
big panel, the first big panel. Yeah, those ones. They start off with minus 36,000. 3,600.
What?
Minus 2,000.
That shouldn't. That's fine. As long as they're vectors. Vectors are. So vectors show vectors. Oh, you're getting the point, not the tangent. Are you picking the P or the T? Yeah, you want to use the T. Okay, just a warning, guys. Points and vectors have the same topology. Think about it.
Sorry, say that again?
Points and vectors are the same.
No.
Isn't that because points are vectors, but not all vectors are points?
All vectors and all points are the same.
No, you have to explain that to me.
Okay. Look.
Vector that is going one point from another.
Sorry, Andrew.
Yeah.
Do you do anything to the subtraction?
Huh?
Yeah, I do the minus 180.
Oh, yeah, hang on.
Wait.
Oh.
Nah.
I get how why vectors can be points, but not points can be vectors.
They're the same.
Oh, no, I see what you're saying.
That's what I mean by that.
So, you had a point.
Hurry up, quickly. You ran out of time to explain it.
Here are the points. That point is 0, 0, 0. Right? And then I have another point.
That's so true.
We're going to call this whatever. This is 10, 10, 0. Right?
Yeah.
Now, how do I write a vector? If I had a vector that went from this point to this point,
Oh,
the way that vector is described is by the difference between these three conditions. So it's 10 minus 0, 10 minus 0, 0. That vector is the same as that point. Yeah? The only way it will look different is if this was 20 and this was 30. The vector would say it's 10, 10, 0. But those points, it's obviously not the same as that point. But that is the same relatively as that versus that. But what's the key thing here? They both have,
X, Y, Z coordinates.
yep, and so therefore they have the same topology.
Oh.
Okay.
Cool?
I understand you, but it doesn't make any sense.
What that means is, let's say I draw something like a steel profile, and I want to move that steel profile to this point, right? What I can do is I can pick, get the center point of that, and then measure the vector between that center point and that point, and then move it with that vector. Or I can just draw this steel profile at 0. And then I don't have to measure the vector between them. I just put the point in as the vector. Try it. You can put points into vector inputs and they'll work. Cool? Cool. Huh? Cool, am I saying the right things, guys? Good.
Yeah.
Pardon?
You should be the maths 1A teacher, not him.
Really? Is it more? Okay.
They should go about it in the
Ah, this is a matrix, a 3 by 1 matrix, and therefore if you do a 3 by 1 matrix, yeah, I know, yeah. Yes, but when they teach you guys maths, they don't just teach you geometry, right?
No.
I only do geometry. That's the only maths I do. Did they teach you Booleans?
No.
What? Okay, Booleans are really cool. Okay, another trick with Booleans, guys. Do you guys understand? Do you guys know and or functions?
Yeah.
Yeah. So let me just run through it. There's guys, this will be just a little reminder for these guys, but it will also be useful for you. So Booleans run through and or. So what I can do is I can say, hey, here's a condition. Everyone in this room who is wearing a black jumper or t-shirt, a black top of some sort, put up your hand, right? And everyone here who thinks that they're wearing black is going to put their hand up. Kerry's not listening. Okay. Neither is Carson. A top. A black top. Okay, so there's four of us putting our hands up, right? Now I can do this next condition, which is everyone. Is this gonna work? Yeah, it's true. So that was one condition. Now I can throw those conditions into and or, right? So if you put up your hand if you're wearing shoes, not boots, or you're wearing a black top. Right? So Sarah's wearing.
Are you serious? More people are wearing shoes.
Yeah, I know, but Sarah's wearing boots.
Yeah, no, but
Yeah, they're not listening to me, Matt. That's the key thing. Put your hand up if you're listening to me. Okay. So that or meant that because even though Sarah didn't comply, yeah, it took a while. But that or meant she had to check. Oh, am I wearing shoes? No, I'm not wearing boots. Oh, okay, I shouldn't put my hand up. Oh, but he just said or wearing a black top. I'm wearing a black top. I'm going to put my hand up, right? Because of the or. If I said put your hand up if you're wearing sneakers or shoes and a black top, then there's only three of us doing that, right? Because Sarah doesn't comply with that. Oh, no, Kerry's wearing... No, they're sneakers.
Is it like Venn diagrams?
Yes. And this is where the keyword Boolean comes in, right? Because when we use the word Boolean in geometry, what we do is we're doing a Venn diagram. So, true and true equals true. And that also relates to a Venn diagram or a Boolean geometry function. So if I have two circles, anything that's inside the circle is true, and everything that's outside the circle is false. So this is true, but it's false. This is true, and this is false and true. So the result of an AND function in Boolean geometry is called an intersection. And then, so OR would result in, so this is true and false. So an OR, so a true and or a false equals true. So this is true or true and false, so that would return true. That's true and true, so that would return true. And that's false and true, so it would return true. So that would be that, a bum, which is called a union. Yeah. And then there's...
Union is an or function.
Union is an or function, yeah. And then you've got... The last one's a bit funky.
Someone had said Venn diagrams. It makes so much sense.
Big brain.
I wish someone had said it's like Venn diagrams. I never really understood it.
Then you've got true, not true. By the way, all of these results are, if both are false, they're always going to be false. So false is almost like the default outcome. By the way, we're going to turn all of these into maths functions in a minute, okay? But true, not true means anything on the opposite side, or anything in the second function that is true is false, so it flips it. So these all get turned into falses, and that would then result in a cut. Oh, then that's true. So that would result in that shape. And that's a difference. Okay, so so we're doing shapes, now let's do maths. If I have, now this really simple maths, guys, I want you to take your brains back to year one, or maybe year 2 for some of you. If I have true, and we're going to do some weird algebra, and I do something to it, to false, and that results in true, what would I be doing to that?
Multiply.
No. Wrong.
Oh no, addition.
Yes.
Or subtraction. Why did I say multiply?
Addition and subtraction are actually the same thing, in theory. Yeah, yes, because all you're really doing is if you make one of your numbers negative, then that's subtraction. Cool? Yeah. Subtraction is also really weird because it matters which order you do it in. Right? While addition doesn't.
Wait. Yeah.
Huh?
Subtraction doesn't matter which order you do it.
Yes, it does.
Yeah, it does.
5 minus 3 plus 1, 3 minus 5.
Between us and between us and
10 minus 0 is 10. 0 minus 10 is minus 10.
Your point has been made.
But addition doesn't matter. So 0 plus minus 10 and minus 10 plus 0 end up being the same.
20.
HT. Okay. So addition is the equivalent of OR. Because what happens? What if I have another true value in there? What happens? What does that become? 2. And what would that be in true false? Yeah. Wow. So no matter how many zeros you put in there, it's always true. Right? Now, what do I put in there to make an AND? If 1 but 0.
I got the answer for this one.
Yeah, you did. Yeah. As long as there is a false value in your list, you can have as many 1s as you want. As long as there is a false, you're going to get, floored at 0, always, right? So, multiplication with Booleans is, it's false. Multiplication is and addition is OR. Huh? It can be used with probability, but it's not probability. It's Boolean.
I'm guessing Booleans make probability.
Boolean helps the maths of probability. Yeah, then I would not say this is probability. Because I have to start teaching other things.
He doesn't get paid for that.
No.
He gets paid for this.
I don't even, my job description doesn't even say that I get paid. I get to decide what I teach you. It's really weird,
Teach us something easy.
No. No. As in the uni as an organization doesn't know what I should be teaching.
I can teach him. I'm just you're hired.
Yeah.
That's it.
They go,
You can do whatever
when you're a tutor, they go, okay, you're hired, this is what we're teaching them today. Go. Right?
There isn't it's very obvious there is not a curriculum for this course.
There is. What do you mean?
Well, if if there was a curriculum, it would tell what each subject would teach.
There is a curriculum. There is one. You just
How's the uni not know what you were teaching?
because the curriculum doesn't state. It just says, you know, in this particular class, you're learning about building data. I have to come. My course. So I've designed my course outline, but the program director hasn't told me how to deliver that course outline. They've guided me how to do it. I've had to jump through all these hoops, like learning how to be inclusive. That's why I've made that Asian 1-1 joke. I know that, by the way, because China and Japan both use the same sound, and my wife's Japanese, so she gave me that joke.
Did you like it as much as you do?
Yes. No, sorry. No. She thinks I'm a dork. I have another Japanese joke, but you guys don't know. You know Japanese to know it. So
I'll learn my next lesson.
you need if you're gonna learn, you got to learn body parts and specifically about hair.
I'll focus in on biology.
And just hair,
Okay, sure.
right? Like what do we call this?
Eyebrow.
Yeah, the Japanese have a word for that, right?
They don't?
They have a word for it.
Eye.
And what do we call this? No, the hair. The hair. Yeah, and what do we call the hair here? Yeah, right? Like there's words for all of those things. Yeah. My joke has to do with that. And also the word, and also the word for teeth.
Okay, this is interesting when gone past.
Yes.
Weird game of head, shoulders, knees, and toes.
It is, and it's especially funny when you tell old men this joke. It's good. It's a good joke. I like it.
Unfortunately, there aren't any of the head.
Old Japanese men in this class? Unfortunately, yeah, you're right.
This is pretty unlikely, though. I reckon you get some next.
I've had some middle-aged students.
But not all.
The problem,
I'm 25, okay? 25.
the problem, what I find is I've had like a 40-year-old woman in the class, and this was like first term, and so she's like, how do I open Rhino? And I'm like, you're in the wrong course. Like, if you don't know how to use a computer, you're in the wrong course. So she dropped out. But I said that in the nicest way to her, by the way. I'm like, you need to find something. No, yeah. Okay. So, we now have a conundrum. There's two conundrums in this. One of the conundrums is that depending on where I started drawing my L shape, the order in which you will see the 1 1 0 1 1 1 is going to be different, right? And there is another conundrum. If I select this L shape, what do I get? No!
It's the same.
Shape. It's the same shape. No, it's not.
It's the same.
Start
Order or whatever.
It's the same order, but what's different about it?
It's reversed.
No, it's not that it starts at a different point. It's actually starting at the same point. You can see.
So instead of zeros, it's one.
Yes.
Because it's going the other way. It's facing the
It's because of the order in which the points are drawn. It's going the other way. Okay?
It's not facing the other way.
It is. It's facing the other way. Yes. Everything has a direction. So, when you draw a circle mathematically, if you use the tan, if you use the angle and a sine function or a cosine or wherever, I can't remember. I think it's cosine. Maybe What? When we draw a circle with maths, as you increase the angle, the way the maths function, I think it's cosine,
Yeah, it is.
works is what direction does the circle draw in?
Anti-clockwise.
Yeah. Which like we've always said clocks go this way, when in fact they should go the other way, mathematically speaking. Okay? So computers draw everything if you by default anti-clockwise. Humans don't. Right? So my anti-clockwise shape, I don't even know if it's anti-clockwise yet, we'll soon find out. Because I might have drawn this one the wrong way and this one the right way. We don't know. We just know that we decided that negative things that are greater than zero, smaller than zero, are going to result as a 1, right? That's my decision, not maths. So how do you work out which way these are going? It's a very complicated question. But the key thing is here is one is drawn clockwise and the other one is not. And that is going to fuck up your lives in the future with all the Grasshopper scripts that you write that other people are going to give you inputs for. Because if ever your script relies on a closed curve needing to be drawn clockwise or counterclockwise, someone's going to draw it the other way. And Eddie's asleep. Does that make sense? Okay, so how do we do it? I don't expect any of you to come up with it in your head unless you actually know how to do it. I normally have to go to fucking Google to remember it, but it is I believe the formula. I'm going to take a stab in the dark before we go look it up. But yes, it is. If you take, this is basically like rudimentary calculus. Okay? Huh? Yes. So all we're really doing, and I might as well just get that vector diagram that we did before. Stop. All we're doing is we're taking the coordinates of.
Are you using differentiation?
Yes. Yes. Yeah. No. We're just. Yes, if the final shape is either negative or positive.
Oh yeah. Great. Yeah.
These guys know it. Good. Yeah. There are things that actually relate. That's why this is an elective. Okay, but I'm going to teach these guys what it's doing. Huh? We're going to call this 1 and this one 2. And I'm going to have to remember it. I'm not going to. I believe it is x1.
No, why?
No.
It's rise over rise.
Let me take a stab in the dark first. Okay? Just let me take the stab in the dark. Because I know there is a multiplication in here somewhere, right?
The gradient?
There's a multiplication. What do you think I'm doing? You tell me.
Oh, I thought you were going to find the gradient.
No, I don't want to find the gradient.
Are you doing second
Differentiating, right? Or
Yeah.
integrating.
I don't want to find the gradient. That's not going to help.
Yeah, it's like x plus y. Then it varies times x plus y. And you put that into
What was it? X?
x plus. I think it's x
Is
plus.
this the
I don't know.
equation of the
No, go on.
Are you integrating or differentiating?
I cannot remember.
But if you find the
Differentiate.
gradient, would it let you find, let you see the direction of the line?
I don't want to know just the direction of the line, because what we're eventually going to do is that we're going to look at all of the differentiating numbers of each of these and add them together. And they're either going to come out positive or negative. And if they're going clockwise, they're going to come out negative or positive. And if they're going counterclockwise, they're going to come out the other way. And I think that is done with x1 plus x2 times y1 minus or y2, or a combination of those. Maybe flipped. Let's find out. Danae, write down what you think it should be somewhere.
I'm just confused.
Clockwise. How to check if a shape polyline is clockwise formula. And Rebecca, this is why I'm totally fine with you going and copying shit. There we go. X2 minus y x1. Times, that's why when you said, no, it's y, I was like, you can be in any order. Y2 plus y. You know what I mean? Yeah. Yeah, I know what you were talking about, getting the gradient.
Yeah.
Yeah, that's easy. I would have known that. Yeah.
We don't need no gradient.
I don't need your gradient, although I do use gradients occasionally to check if a line is collinear for my laser cutting scripts. If it's negative, the curve is counterclockwise. Okay, and hang on, I just want to get what the actual word of this is, because it could be for the future. If I do have engineers, I don't look like an idiot like I do in front of you guys. What is it? It's calculus applied to a simple case. Yeah, it's not any of the things you said it is. It's just calculus. Done. That's fine. That's fine. So you saw that there in that was this Stack Overflow maths? Did you know there's different Stack Overflows for different things? Yeah, there's like an engineer's Stack Overflow. It's a bunch of engineers telling each other how to write formulas. So I've forgotten how to do this. It's like, here's a link to another question.
How'd you add?
Oh, trust me, if you asked a mathematician that question, they'd be like, oh, have you got the next 24 hours?
No.
How do you add? I'll prove how you add. You know what I'm talking about? Yes. Okay, so the formula is going to be x2 minus x1 times y2 plus y1. Oop, oop, oop. Yes, thanks, When?
When you put in an expression, do you have to put in the because in math, like in high school math, you didn't have to. You don't put time between the brackets.
Computers don't know. No, computers use a different syntax to mathematicians.
Yeah, no, so I was just wondering, do you have to use the star?
Yes. The problem is that computer scientists use similar syntaxes and symbols to mathematicians. So, to a computer scientist, this could be a tuple with a maths function inside it, right? To a Python language. So, because we use curly brackets to make arguments, right? So it could be a lot of different things. What we're going to do is we're going to make an expression that does this. But in that expression, our second values, so x2 and y2, we're going to use u and v rather than x and y. And we can change that in the expression to u, and we can change this guy to v. You can actually manually change these. I think you guys know that because some of you use it in text, big text. And so we're going to go in and we're going to change x2 to be u, and x1 to be x, and y2 to be v, and y1 to be y. So what we're doing is we're going to add this as a nice little check that happens before we do our topology. This is actually a separate script, and sometimes depending on how I run my course, this is actually done in a separate class. But what we do is we're gonna almost run this same type of function, you know, where we explode a curve, we get the vertexes, and in this case we can rely on these vertexes rather than running an evaluate. Does this give me duplicates? 1, 2, 3, 4, 5, 6. Yes. So, by the way, explode, if you've got a curve that's looped, then explode will always give you the first curve and so first point and last point, which are the same. So we want to cull them. Has this class been at least a little bit relevant to you guys? Yeah, cool. We are going to explode the points or the vectors, you know, because they're the same. And we want to shift these as well because we want to shift them along one, because we want to compare this point to that point and that point to that point and so on and so forth. So we need to add that shift list in. We're going to deconstruct those points as well. And the x goes to the x, the y goes to the y, and so on and so forth for the u and the v.
Can you please
Slow down.
lower the thing?
Ah, yeah. Sorry.
Thank you.
That is going to give us the calculus results. Oh, I think this, oh, no. We're going to run that through a mass addition. And we can then make a little checker. Now, if Stack Overflow is telling us the truth, which sometimes they're not, just be mindful of that. Sometimes you aren't getting the truth on the internet. If the result is positive, the curve is clockwise. Let's just check. Let's draw a counterclockwise shape and plug that into our system. Using that as a result, we're getting a negative number, and they're saying negative the curve is counterclockwise. That's true. I just drew counterclockwise. Perfect.
Sorry, how did you add additional variables to the expression?
If you zoom in, you should get a little black plus.
Because of areas, apparently.
Pardon?
The area of a counterclockwise shape is like negative, and the area of a clockwise shape is positive.
Yeah. Yep. And we care about this because now that we've got a shape, if we want to work out what that shape's plane is, we have to basically take the starting point, the next point, and the last point that aren't collinear to define that plane. Now, if that plane, that is now dependent on the order in which that was drawn. So if you drew it counterclockwise, the z's going to point up. And if you draw it clockwise, the z's going to point down. And that's why we're getting, when we compare the vectors of each of our angles to an xy plane, that's why we're getting a flipped result. So the convexes are coming up false or true, and we're gonna see if which one is the right way in a bit. So what we want to do is we want to check if this is positive, because what we want is we want all of our shapes to be counterclockwise, because counterclockwise is the best way. If you draw any shape, in Grasshopper, they're going to be counterclockwise, always. I really hope this doesn't make me wrong. Here, so this is drawing a hexagon. That hexagon is counterclockwise. You see that? if I draw a circle, by the way, this doesn't work on circles because circles don't have segments. So, but if we turn that circle into a bunch of segments, we'll get it working, man. It'll work. This shape is counterclockwise, okay? So it's drawing everything counterclockwise. We might as well follow along. Listen to our overlords. So if x is small, if x is larger than 0, then we don't want to flip it. If it is, so we're going to use the if-then statement. By the way, so you learned a little bit about if-then with Python. Dispatch in Grasshopper is how you do if-thens. You basically generate false true value. So this is the thing that's doing the evaluation. So that's the if. And then anything that comes out of A is then, and anything that comes out of B is else. Cool. So we don't want to flip it if it's counterclockwise. Oh no, we don't want to flip the number. We want to flip the curve. Flip. And if it is counterclockwise, we flip it. Weave will get us back together again. A is true, true is 1, B is false, false is 0. The expression for weaving goes back into there, and we can throw this curve out now, knowing that it's always going to be counterclockwise. So if I were you, I would throw this curve. If you do this, so just plug two curves together, you can select your window of that small little function there. That's a nice little snippet of code. Let's turn that into a cluster. Bam. So if we double click into that, that's got that snippet, but now it's just nice clean. All this does, put any curve into it, it's going to turn that curve in. Make it either, it's only going to make it counterclockwise. Cool. What does that leave us with? A bunch of 1s. So, convex is 1. Concave is 0. If I go back and select, oh geez, I'm flipping all over the place with this script, sorry. Zoom out a little bit. Back in. If I go grab that flipped list, so this is drawn the other way. I'm not running on power. Okay. Then we get the same result. So even though they're drawn the wrong way, the system now draws them the right way, checks them, and sends them through. Now, this is an important lesson to be learnt with building data, right? What we've said is our script will only run, sorry Eddie. We've said our script's only going to run with counterclockwise shapes. And we've checked if they're clockwise and we've made them counterclockwise. You guys are going to be sending geometry to each other that you might assume is drawn a certain way. You have to agree on how that's going to be drawn for things to work. And you're certainly going to have to do that when you're working with consultants. Because your consultants are going to expect that stuff to be drawn a very specific way with very specific units. What units do you guys use? Meters. What units do architects use? Right. So you got to tell them what unit you've used, or otherwise they're going to give you something either 1,000 times or 1,000,000 times what you gave them, right? Or possibly even 1 billion, depending on what they're measuring. Cool? Is it 1 billion? Distance is going to be 1,000 times. Area is going to be 1,000,000 times, and volume is going to be 1 billion times. Yeah. Cool. And they like working with volumes. I can tell you that, right? You like working with volumes. You have to work with volumes. Cool. Okay, so yeah.
Can you please give us a moment at looking at what's in that cluster, please?
Yeah. That just as you guys, if you need me to slow down, tell me, okay? I made that cluster really quickly. Huh? Yeah.
Yeah, we were just watching.
Do you want me to re-explain it? I don't need to re-explain this thing though, right? Stack Overflow can do that. We're exploding the code. Exploding the curve. So therefore, we're getting the vertices that define it. We're culling the last one because when you get a periodic shape, so a shape that loops back on itself, it gives you the first and last point, even though they're the same. So we need to get rid of one of them. So this is just culling the last one. But you can also cull the first one. In this case, it doesn't matter. We're shifting the list, so that's taking every item in that list and moving it along one, so that when you compare the first item in the first list and the first item in the second, they are incrementally being compared. We're deconstructing them to get their x, y values, running them through that expression that we got from Stack Overflow, and then adding them all up using this mass addition function. We're running a greater than expression, which gives us a true value if that final number is above 0. That final number, if it's above 0, means that it's clockwise, and we want everything to be counterclockwise. So anything that comes out of true, so therefore A, is getting flipped. It's getting woven back together because, you know, we could actually potentially have multiple curves getting tested in this. So that's why we're weaving it. And then we're returning the outcome, that flipped or non-flipped curve. Let me do this. And you guys can see why Grasshopper, I actually think Grasshopper is a much better environment for geometry coding because it's visual, and geometry is quite visual, or at least to most humans. Oh, you can write geometry in Python, but you have to write it in Python, right? You can code, well, mathematicians code in geometry, but they're not doing it to make shapes. You guys have probably had to do structural moment diagrams and stuff like that, and that's all mathematical geometry. Like I'd rather draw it. Yeah, but what's interesting is engineers also use Grasshopper. Like Arup, I have friends at Arup that use it, and I've sent them Grasshopper scripts, and they've used those. But they are specifically structural engineers, because structural engineers are a special beast of engineer that is really about geometry in its form, and, you know, drawing things and checking that it's all matrix calculations and finite element analysis. So it does lend itself to this. And then sometimes engineers are also trying to optimize geometries, so they want to relax your geometry so it is more efficient. Even though you're using the same amount of steel, you're actually getting a better structural result because you've used a specific curve. That's a drawing exercise, it's drawing and a maths exercise, not just a maths exercise. So huh? What did you say? You're right. I find, yeah, sometimes it's like, how intimidating can you be? Can sometimes determine like how well you go in that period. But this is the other thing. If someone knows how to like record emails and write their emails the right way, they trump all intimidation. Because it's like, you said you would fucking do this, you know, and then you go, no, I didn't. And here's the email, like, here's the list of emails that proves that I said I wouldn't do it. You want to share your screen? Just share. So, who's good? Is everyone good? Eddie's not good because we've been falling asleep again. Am I that boring? Okay. I didn't think I would. I felt like I was at least teaching. Okay, good. Yeah, because I've been in classes where the teacher's like, bah, 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 and I'm like, oh my god, I'm falling asleep. Bah, 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 bah. Ah, yes, the aggregate. Huh?
How come my cluster has 2 inputs and your cluster only has Studio 2?
Because you might have done, when you turned it into a cluster, you might have had like multiple things plugged in. So you'll see there'll be another, when you open it again, there'll be this little input. So you're sharing? Are you sharing? Can you try share again? Max, you've got your hand up for some reason. Why? Okay, good. Pardon? Yes. You've written that in, that needs to be in a cluster. Select it all and turn it into a cluster. You're not in a cluster. Yeah. Hey, also, by next week, I want you to get the desktop version of Teams so I can remote control your computer. Middle click. Cluster. Cool, now plug a curve in. And what's your curve output? You'll get a curve. You should get a curve out of that CRV output, right? Go click into the cluster. Just click into the cluster. Double click. Your B needs to be plugged into 0 in here. See the dispatch? The dispatch B needs to be plugged into the weave 0. Done. Save it. I hope this is recording. Cool. That's giving you a curve. You good to work with that? Okay, everyone else is good? Internet people are good? Now I will make sure I'm sharing the screen. Cool. Okay, but so what we've done is we have solved clockwise, counterclockwise, but what we haven't solved is which point we start drawing, right? Because look, let's try this. 1, 1. We want to draw counterclockwise, so.
You already finished your degree.
Okay, and so the top curve is giving us that result, and the bottom curve is of those L's is giving this result. Are they the same? Like they're not the same, but they're also they're not in the same order, but they're the same. Like if you loop them, they are the same, right?
Yeah.
So what we want to do is we want to start defining. Like if we want to work out what the shape is, we can take a string like this, so that 111 011. if you write that 3 times in a row and then run this function through a match text with regex, is this going to work? 1, 2, 3, 4. No, that's not going to work.
So my thing's gonna reload from 0 rather than.
How did I do this before? I've taught this class like 3 times.
I think I remember.
You didn't do this one. I have ways of solving this. We'll just do it that way. I must have done it this way. Okay, so if I run, so are you guys aware of what regex is? Have I? Me, it's probably me. Did I show you a website? Okay, I'm going to show you regex. This is going to be important to you guys, by the way. You should listen to this. Sorry. No, I don't mind if you talk. It's fun. But I think this will be important to you. There is another language out there, a coding language called regex, and it's a special language for pattern matching in text. And it is very useful for renaming files or renumbering files. It is very useful for finding things in text that you might need to find that might be a variable. And if you go to this website taught me regex. I didn't use any other thing other than this website to learn regex. Regex works in Word, it works in Excel, it works in Grasshopper, it works, I don't think it works in Adobe Acrobat. It works in Python, obviously. It works with the RE, import RE. So regex is, the module is called RE. It also works, if you're not using Acrobat and you're using something like InDesign, it works in InDesign. Regex. It's a pattern matching code. And let me just demonstrate. When I want to go find, let's say I want to go find the word regexa. I can look exactly for regexa and that will find it. And that is an exact match, right? What regex lets us do is it lets us write code like, let's go find all the words that start with a capital. How do we do that? First, we can say, hey, go find all capital letters. And so the square brackets here are telling us, okay, look for any A to Z in here. And there are combinations that we can do. So we can say, then find any character. So by the way, I'm not going to teach you guys regex. If you want to learn it, you have to go learn it yourself. This website will teach you. You can see here that dot means any characters. So that's how we're getting R, E, or EX. It's finding any capital letter with any other character. And we can repeat that any letter until we get to the end of a word. And look, now we're getting all words that start with capital letters. Why you would want to get that, we have no clue.
Website's called
Pardon?
just regex.
The coding language is called regex. The website's called regexr. I don't know why. There are, if in your careers, all of you are probably going to have to rename files. There are tools out there that are free, like bulk rename utility. So bulk rename utility lets you do regex replacement. So for example, if you've got
You know what's keeping me in a job is human.
What's keeping you in a job?
Human inefficiency.
Oh, yeah. Definitely.
And that's the only reason I'm not scared about automation.
True. I agree with you. That's how I've got a job. But this is the thing. Like, everyone in this room is going to have a job because they're making someone else's job more efficient. That's kind of what code is. It's you're making a task more efficient by doing it as code. Now,
Basically destroying them.
yes, but the next level to that is coders also destroy their own job.
It's cutting yourself. You just need to make enough money. That
No, because you spend a week writing a script, and then you can run that script, right? And then you might spend someone then might ask you to make that script user friendly. Guess what? You're no longer the person writing the script or running it. Sorry, you're not running it anymore. Someone else is running it. So you've lost, like you've effectively made something where you have to be involved, and then as you get better and better and make that more advanced, it means you don't have to be involved. And that's how you make money. Because then you can charge people for something that you don't have to do any work on. Yeah.
So that's why you want to own this code.
Yes. Which you won't, well, yeah, and you work for if you work for someone, you won't own the code. Yeah. Which is stupid. It's fucking stupid. But whatever. It's illegal, by the way, if you work for someone and you put some kind of like thing in your code that once you leave the company, the code stops working, you'll get in big trouble.
Right? Okay, good to know.
Yeah, don't do that.
I wasn't planning, right?
Good. Okay, look, here's a really good example. Let's say I've got a bunch of files that are called ABC125, UJS883, and that number is describing the revision. So when we work on jobs aren't always going, like the design's never going to be the same, and we have stages in the design where we issue drawings, and those drawings go up. And for some reason, this drawing ABC has had 125 revisions, and UJS has had 883 revisions. Depending on the job, maybe that could be the case. And someone somewhere has said, I don't want revisions written this way. I want them in square brackets.
And then you tell them they're a dick.
Yes, but then you have to go and look at, and I'm not saying this is going to happen to just 2 files. You could be looking at 500 files, and some poor person has to go type that all in manually.
I've done that.
Yes. A lot of you are going to. I'm telling you this because everyone here is probably going to have to do this one day, and you're going to save yourself like a day's work, possibly every week, if you know how to do this. Okay, so that's what I'm telling you. Plus, we've got an hour left to finish the other thing, so we're good. So look, what I'm doing is I'm looking for A to Z in lowercase and uppercase. You can see that? And I want to grab that all the way up to, I want it to get it repeated. And you can see there it's selecting all the ABC, UJS as a group. What we can do is we can actually throw them into a group. I wonder how this actually works. I can write the group number here. No. Here? No. Do I just do this? I've never done the replace function with regexer, but it's just a demonstration. Yes, okay. These greater than's and less than's are. Yes, cool. So by putting these in curly brackets in regex, what it's doing is defining anything that it captures in that into a group. So what we can do is we can also go get groups of numbers. So in this case, 0 to 9. And that's putting that in a group, right? So when we're running when we're running that as just a search or a match, it's getting everything. But what it's also doing is it's putting those two patterns that we've written into those groups. And so you can see here in the tools with a replace function, we can replace group 1 and group 2. Look, we get the same outcome, right? Right? So we can then say, hey, throw group 2 in square brackets. Bam. You've looked at the pattern and you've put everything into the groups they need to be, and you've given it the pattern that it needs to result in, and you're done. Yes. Yep. Look, watch this. Whoa! Oh, you can do whatever the fuck you want with it.
As in, like, can you, like, from creating those groups, could you, like, then make a list of, like, all of the first group?
Yes, totally. With Python. Yes, totally. You can look, see this list? Look, you can check this out. You can, if you want, you can just go to regexa, copy all your file names. Do you know how to copy file names, by the way, as a list? This is another thing you guys need to learn. Okay. Web browsers are also file browsers. So if you go to, I'm going to go somewhere that actually has something in it that isn't compromising. Okay, this. If you take the location of a folder and you put that into a web browser, it'll give you a website that shows you those files.
And then if you highlight,
The browser's programmed to allow you to do that.
if you highlight
Yeah.
the name,
You can select them now as text and copy them. Right, so how do we do that? We use Sublime Text, a free program. Or, you know, it's $75 if you want to pay the guy, and you really, if you're doing this at a company, you should maybe, like, if you're like, oh, hey, I'm using this program every day, you should encourage them to pay. Okay, so here, we paste it into Sublime Text. We get, it's a bit of a jumble of crap, but look, what is separating them is tabs. So you can, in Sublime Text, selecting a tab, we can go Alt F3, oh no. Like that, that's selected every tab. We type in the left keystroke, which now it's no longer selecting the tab, it's selecting left of each of the tabs. And then I'm going to hold Shift and then press the end button, which is going to select to the right, all the way to the right of each of the lines. And then we delete, and now you get a list of all your file names. Cool. That is a non-coder's way of doing it. You can also write a Python script that you point at a folder and it just tells you all the files in that folder. Or we could also do this. The reason I tell people this one is because then you can go tell your colleagues how to do this. Rather than sort of saying, hey, go to CMD and CD, bloop. That's not going to work. See, there's already a caveat to this, that they need to know what they're doing. CD, bloop, derp, text, copy that, paste it, right? Gone. Oop. So there's a few ways to do it, but the web one is, I think, an easy one because it means, like, people who are scared of this, people are a bit scared of this. It's a bit easier for them.
I know a good way to do it.
Another way, just wait, bear with me. One other way, I like Sublime Text. I just like it. But there is another way And so you guys with Sublime Text, you should do it that way. But you can also, when you copy this, it's copying tabs. And so if you paste this into Excel, the tabs are going to recognize and they're going to delimit, and you're going to get all of these in columns. Is that what you're going to suggest, Declan?
No, I was going to say, you just put it on one side of the screen and on the other side of the screen, and you just type it up.
Oh, yeah, you could do that.
It works pretty well. Sometimes there's spelling mistakes, but otherwise.
What? Well, now everybody can fucking do it, right? Yeah, you can give this to a bloody director of a company who's 50 and they'll know how to do it. Yes, they, if you, huh? So you do this? So you know, yeah, you know how to do it. You do this exact thing. You go to a website, you put in the address, web browser, you copy it into Excel and you're done. Bam. So, check it out. Copy those. Boom. Throw them into regex. And that will give you that list that you're looking for if you want. Like you can just copy that list out depending on what you want. Hang on, let's do, that's not going to work. These are all fun. Yeah, but that's, so a great program that helps you do that better and actually rename the files is called Bulk Rename Utility. It is an intimidating file, program to use, but it is awesome. It gives you every possible thing that you might want to do in terms of renaming files. It lets you do the regex functions in there. Hang on. It lets you write code. It's free. Where is it? It is, dude. It's great. Yeah, look, it's great. It's great for photographers, but there it is. It's the first option, regex, match, replace. And that's in there that you can write all of those regex things. Yeah? Okay, it's free. You just need to convince your IT person to let you install it on your computer. That's the hardest part. And then also learning regex. Okay, back to stuff that won't get you a job. Is that like, if seriously, if you walked in, if companies knew this, if you walked in and was like, I know how to rename files, they'll be like, you've caught our attention. I know document controllers that don't know this stuff. And they should know it. This is their life, is renaming files. And they don't know how to rename files.
If they do it too well, then they'll lose their job.
No, they will get a pay rise. Because what will happen is, rather than working on one project, they work on two. And they can say, I used to work on one and you paid me this much, and now I work on two in the same time, pay me double. And the company will go, fair enough.
Double is productive.
Yeah.
Maybe like hand setup, we don't need to hire another person.
Now, mind you, renaming, this is probably not going to get a document controller's time down by half, but it's an example. And usually you get exponentially diminishing returns. So they won't pay you double, they'll pay you 50%.
Still more though.
But look, what we're doing is I'm using this match text. We can use another one, but what match text does, it allows in here you to run a regex search. And so we can search for our string within this string of 3. So if you repeat it 3 times, what it does is it makes sure that wherever your string is going to at least exist in that triple combination. So that's going to return a true false value because it's purely a match. So that's true, that exists. Let's go get the other shapes, because we're going to run into a problem. So let's go get a T. Also, we are going to want to do this. We've got plenty of time. Plenty. See, this is what happens. We move that class from that bloody lecture theatre to here, and I feel like I've got like plenty of time. It's just that room. It's not a good room for teaching in this type of stuff. So this is a T. We're going to copy this, and we're going to run it 3 times. So this is the topology of an L. This is the topology of a T in convex concave binary. We don't need to understand it, just the computer needs to understand it. Let's go get the U, and then we'll go get the rectangle last, and you'll see why I've chosen it last. You guys have a think of why rectangle might be a problem. What would a rectangle be? No, wrong. Rectangles are not squares most of the time. Only in specific circumstances are they squares. Okay, what is the result I'm going to get when I get a rectangle? Yeah, how many ones? Yeah, and do we have 4 ones in order in any of these others? Yeah, so unfortunately, rectangles are going to say that they are, like, rectangles are going to match with all of these.
You could couldn't you limit the strings to like a certain amount of numbers?
It's hard. How are we going to do it? And I think maybe it shouldn't be last. Maybe it should be first. Yeah, I think we'll make rectangles first. Okay, so we're getting a true-false list. So, like, giving us true falses versus it matching with these, and all of them match true. But we can caveat that to say we know when we use a rectangle, it's going to come out true for all of these. So when we do run this dispatch, we can always just run that through a list item to always get the first one. So that's telling us that's a rectangle. Why is that not disappearing? That should disappear. Go away. Buggy grasshopper. I feel like sunglasses is doing this. So what that means is, so rectangle is coming out true for all of these. We're dispatching all of the true ones, and then we're picking the first one because these shapes can only have one. So we'll always pick the first one. Then if I point this at an L, it's an L, right? The outcome is L or T, because apparently you can have L's in T's. See, look, there's an L, right? That's the same, it's the same topology as this one. So what we're going to do is we just sort it, but in order of the quantity, which is what I've done here. You know, they're only ever getting larger. And then you always just pick out the first one. Because if you pick a T, the T is not going to find itself in L or a rectangle because there's far too many points to check against.
Sorry, how many like the panel with all the ones can you go back to?
Yep.
And the panel before that?
Yeah. It's just we can do this. Rectangle.
That next to
Pardon?
It's like, it could be an L or a T, but it's picking the one,
Picking the first one.
like the one with, like, that considers most.
Yeah, so we've ordered, so this is actually a lookup table where we've said, it's actually opposite. We've said this equals rectangle, this equals L, this equals T, this equals U. Now, in that with lookup tables, normally you want, a lookup table usually functions where you only want to get one outcome. But what we're doing is, because we're running it through a match function, it's returning a true false value for each of those patterns. Now, the patterns are ordered from shortest to largest. So if you have a rectangle, then that rectangle is going to find itself in rectangle L, T, and U. So we pick out the first one, because the first one's going to be the shortest one. The L is going to find itself in T. So it's going to return L and T. And the first one is L, so we pick that one. And T and U are only going to find one result. And when you pick the first one of those results, they're always going to be T and or U. Right? So it's just, what we're doing is we're shortcutting a little bit, we're shortcutting a lot, because there are far more, what's the word? Sophisticated ways to do shape topologies, but this way works for what we've agreed. I've agreed with you guys that I'm only going to give you rectangles, L's, T's, and U's, right? And therefore, you can then say, oh, that's our assumed space to work within, right? The reason we have to do that is those shapes could be any fucking thing, right? There's infinite different shapes that I could give you, and they could be all over the place. And that would put your lives in hell, because we'd be here for the next 10 years instead of the next 6 weeks, right? So now, look, I feel like I've given everyone enough ammunition to be able to start the next assignment. And this is really important for the floor plan and the roof designers. You kind of need to know whether or not you're working with a rectangle, an L, a T, or a U if you're designing a floor plan. If you don't, you're fucked, right? Like it's just going to be a mess. And so this is just going to help you compartmentalize how you're going to approach it. So you have to be in groups by the end of today. Okay? Because if you don't have the groups, then you're not going to be able, I need you starting this assignment pretty quick. The second thing is, when you also need to decide who's going to tackle what. Do you remember what you have to tackle?
Facade, roof, and floor plan.
Yeah, something to relate to them. Just to throw out floor plan, the location of lift cores, fire stairs, and columns, pretty significant thing to have to work out for a building. That should be the first thing that you start with. Facade person needs to know where the floors are, because they need the glass to sort of line up with that. But then you're in a little bit of a creative space with how you want to shade your facade, how you want to divide your facade up, etc., etc. Just remember, not every side of your building might need glazing. Facade doesn't just mean glass, it also means, the solid parts as well. And next week is not a teaching week. The week after, you will see, when you start getting my inputs, you will see that geometry that I was talking about, the positive and negative things starting to appear. So surrounding your building, you will see some water. The facade person probably wants to make sure that building can see the water. Did I mention why? Because we're all here to make money, and you're getting hired to make money, and the person making money off you is making money off that view. So give people the view, right? Huh? Just do it, right? Well, that's money's we're all here to make money. It's all about money. It's all about money. The reason I'm teaching you is getting paid, right? and as well, I get to know you guys, and I get to eventually hire some of you, and that's a really good thing for me. That helps me make money. Money. Yes, we're all here for money. And I guess in a way, then you can translate that to we're all here to survive, So, roof. Roof is going to need to know where the columns are because you want to support your roof off the columns. Roof is going to need to know which way north is because you're going to want to put your solar panels pointing towards that. Blah, 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 blah. Start as soon as possible. You three. We're going to have to come up with, because I have no idea how you guys work. I do have an idea. That's not true. I have an idea of how you work, but each of you are a little bit different from each other, right? So, yeah, like Danae's kind of like a certifier. And
I'm a document control actually.
here you go. You're a document controller. So we've got to work out what information we need to get from these guys for you guys to do your work.
How would that work if they do their assignment 2 days before it's due? We have nothing to
Then I have to give you that stuff, which I will. No. Sarah's right. The last thing you want to do is rely on another student to be able to do your assignment, right? So for me to say, hey, if you get your stuff from Eddie, and Eddie's maybe Eddie won't do this. Will you, Eddie? Eddie doesn't do it, right? You're fucked. That's not fair. So I will make sure that happens. But I want. That doesn't. Yeah, I'll make sure that you have the information. If it's so, there will always be a layer to this, which will be me providing you that information, and not the other students. But there is this nice lesson that I need them to learn, and you to also learn, which is agreeing on a standard of data transfer. That's what this course is about: building data. We've been talking about geometry, but eventually it needs to turn into buildings, right? So when Carson gives you a facade, what do you want to be able to judge that facade? And Carson needs to follow that. Or at least Carson needs to explain to you, or we need to, agree as a class, that's not, it's actually difficult to give you that. So what can we do to meet in the middle? So it's that data transfer protocol. I'm sounding like a BIM manager now, right? Yeah. But that. Well, look. What we are not going to do. We're in a way role playing, but they're not going to give any of you advice, okay? They're just going to pretend they're giving you advice their way, right? So they're going to do the work they need to do, but that's never going to come back to you. So your design's not going to change based on their advice, because then what we're actually doing is you might as well be working on a building. So it's not about that. It's just purely about agreeing on that stuff, and you guys are seeing the results of that agreement. So even though I believe that you guys will get information from the students, these other students. But if you don't, I'll give it to you. But I'd love to see that agreed protocol actually work.
Do we have to take approve for that?
No. Everyone here is going to feed data to you guys. And it's going to be glorious. You're going to be like, whoa. It's never going to work in reality, right? Because I'm never going to be allowed to issue you guys in the industry raw data that doesn't have some kind of revision and signature and you know all of that other shit. It's not actually that's not true. I have been able to do it, but in extreme circumstances. And it has like for example, Ken Roswell Arena. So we put a roof on top of Ken Roswell Arena. I'm gonna start getting like one of those. I'm gonna get something like a Nerf gun or something, so I can shoot sleepy people. Kerry's been taking a nap. Oh yeah, okay, that's fine. I don't care. I just like pointing them out. Actually, I'm gonna stop saying it now. Expect pranks. That actually that reminds me. I did this to someone. Someone fell asleep in my class and I drew on their face. Huh? No, it was 2 years ago, 3 years ago. I didn't get fired. Huh? I've got to pick the right person to do it to. Like, could I do it to Eddie? Probably. And get away with it. Would Eddie complain to the university? Kerry wouldn't.
See, the thing is, would you take that risk?
Yes, the university.
I got mad connections.
No, it doesn't. No, you guys don't need any connections. You could just go complain to this guy. And he'd be like, oh, okay, yeah. Actually, he might even report me for what I just said now. You have no idea which student I did it to though, and I don't think they're a student of the university at the moment. Yeah. I know who I did it to.
We have the survey.
Huh?
Yeah.
More work. Why? Oh yeah. No, but he gets paid one way or the other.
So you might as well not do it. You might as well not.
But you don't just sit around doing nothing sometimes, do you? Yeah. Whatever. He's probably not the one that has to do the work when he reports me. Someone else, right? Yeah, there's like disciplinary officers and stuff like that in the university. I know that.
Do they go around with whips?
No, because I've experienced some pretty weird things at the university, like teachers that were getting sacked but didn't want to be sacked.
Most people don't want to be sacked.
No, but the way they reacted to it was not good for the students. And I've ended up talking to those disciplinary, like each faculty has like a disciplined person, I think.
Yeah.
And they're usually the person that's like telling students off for cheating on tests and stuff like that. But they're also there to make sure the teachers are doing the right thing.
How did teachers react?
Huh?
When they got sacked and they didn't react in a great way.
She tried to keep the course running for the students and tried to take them away from the official course.
Oh, she tried to lead them in a different.
She was like, I'm running the submission. Come to this lecture theatre on this day to do your submission. But she wasn't employed. So she was talking to the students via Facebook.
Oh.
Yeah, but by the way, it's hard for the uni to fire people. What they do is what the uni did was they gave everyone a 6-week extension. This was before trimesters. So they gave everyone a 6-week extension and her contract ended. So like as in, at the end of the term your contract ends. So they're like, well, she doesn't work for us anymore.
Yeah.
Fired. That's the way the uni fires people.
It's a very easy, much.
It's a cheap way of getting rid of someone.
Severance.
Yep. Yeah, I also want your GitHub account, your GitHub repo. Cool. You want this code. I don't like giving people code because it means that they don't act like it's far better to follow along the video and actually build it. I don't like people making their code so fucking quickly that you just copy it. I need you to understand it. This is ubiquitous though, so this would apply for everyone. This is also a building block that enables you to actually do the assignment. So yes, I will save it and give it to everyone. Yep. Yeah. No. I've convinced myself. You don't need to convince me.
The next 30 minutes trying to convince you.
Yeah. You don't. You're good. It's like, oh, but no. I've convinced myself. Yes. Why is it not coming out of the screen? Yeah, do you remember when I said I don't think you guys should do TensorFlow? If you manage to get TensorFlow running, I'll give you a HD for this whole course. No. Yeah. So Python anyway is not powerful enough to run TensorFlow.
Yeah, but if you pay,
No.
not even if you pay.
Yeah. It's hard. It's just hard. That's what I said. It's possible. It's too hard for you guys to achieve in a week, because I probably couldn't do it in a week. I warned you. I did warn you. Me saying that I'd give you the HD in a way was me saying it's very hard, and if you do it, if you pull it off, then I'll reward you. But yeah, you'll never do it. I'd never say that someone couldn't do it, because we could have someone in here that could do it. But if they were in here, I'd know, and I wouldn't have said what I said. Like if we had a software engineer here who was like, I've decided to do code and I'm an AI expert, I would not have said don't use TensorFlow. I would have said, dude, you can, or I'd say do to anyone, dude, you don't have to be here for the first 4 weeks. What would I say? Huh? No. I show software engineers this shit and they're like, what? They don't, geometry is a really weird thing for a lot of people. Software engineers are thinking about like data and dictionaries. They're not thinking about vectors and points, and unless they're building like gaming engines, like the actual engine, not the game, the engine, then they don't really think about geometry. A physics engine? Yeah, why would you build a physics engine? Yes. Yeah. How many software engineers how many software engineers make games? And how many make CAD packages and engineering packages compared to games? They're most software engineers are just making games and websites, right? They're making apps for phones and games. So the guys that are doing like engineering software, there's like, it's less than 1%, I think. Because there's not many people that want to fuck around with geometry in the world, right? So ding. Where is it? Can I just say ding, or should you want me to say ding when? 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 Call me Chad. Chad? Jack. Okay. Jack, we're gonna have a chat. We're gonna chat in 15 minutes, right? I need to have a chat with the engineers about what we need to do with them. Because we need to work that out. Huh?
What, they're engineers, they like that kind of stuff.
Yeah. Yeah, yeah, it was never a presentation. Cool. Okay, well I'll stick around if you guys got questions, but I won't be able to hear you. So just send a message via Teams and someone in the room will let me know, okay? But it's worth No, you're fine. I haven't marked them yet, so don't worry about it. Yeah.
Sorry, we.
What about work?
Yeah.
What building is that?
Next DC.
Oh, roof. A facade over a facade. And electrical grid over electrical grid. That's just what a data center is, right? How many redundancies? I've done that. Just the front. Just the facade.
I feel like this data center, they're making it very flashy, and I'm like, surely you want to be like discreet about it though. Like, why do you want to make yourself like look like a
What is it?
So this
Your
is
center.
just this.
Is it showing its data system? That's why.
Is it?
Well, the other thing is with
Like that's the facade.
yeah, that's cool.
Yeah, it is cool, but I'm like, that's like.
So this is the thing. This is
It's gonna
it.
be hard to
Buildings,
understand because it's-
we can't really hide what buildings are anymore. Like if you look up where the reserve bank is, you'll find it, right? It's not like you'll be like it's not like you'll walk past it and be like, oh, where was the reserve bank? It's like that's the reserve bank. You know it's the reserve bank. It's not secret. You can't be secretive about shit anymore. What you have to do is design the building assuming that people know what it is, rather than trying to hide it.
That's true.
So with the reserve bank, we designed the vault to look like the office. So if you've never been in there and you don't have the floor plans, you don't know where the vault is because they look the same. That's how you do it.
So inputs, document, elements, that's the same as mine,
Okay, what do we do?
just did this.
So just explain to me.
Tributes.
Yes, that would
You
be like.
kind of got an idea of, these guys are making facades, making floor plans. They're not going to look like normal floor plans, right?
It's this.
Oh no, mine's gonna be perfect.
Say that would be.
That's not half.
They're not going to look like normal floor plans. They're going to be models. They're not going to be drawings. So you're not going to get any PDFs. You're only going to get
A
done.
document and
What-
elements, which
what
is just a
can you
list
do
of
with that?
tags.
What
And it produces like the most like pointless
all you're doing is some kind of quantity space.
inputs, like outputs of it.
Using that
Oh, you're so good at it, Carson.
Cost enough.
Like making costs, like if you had like $15.
I thought you were just gonna-
But
I
then,
meant instead of just playing.
So you guys are in a group.
It's a cost, right? That's going to be hard.
Do you understand what
Not-
YouTube
not
is?
designing something. The only thing that they're going to design to Australian standard will be the positioning of fire escapes.
So that's your
Yeah, and so you know, like as you
I got like this.
40 minutes of 2 escapes or
Yeah, what's
whatever.
like the name anyway?
But
Do you want to go?
I like sent them a message saying.
unless they send you the data, you're going to get data and you don't teach them, right?
And
Yeah,
this
you
is
said
just
you
you
have
have
to
to
find
find
the
section of the video.
carbon,
just
like embodied energy.
stripped off like
Yeah.
Like we talk about, yeah, we talk about embodied energy.
Yeah.
That's hilarious.
This is video. All this off in
So
the
you'll
video.
find.
I missed everyone else's
presentation. Inside A and then
Okay.
inside B.
I mean,
Like,
do you wanna know?
so-
explain it first?
So, you know, what you get from cloud is,
See if I swap to B, so we're looking at B, which is this part, and then.
you get volume of things.
See,
You
that's
get
what I
volume
was
of
like
concrete,
going
volume
to
of
do,
steel.
and I'm like,
And that's how you work out cost, right?
And
But
then
that's also how you can work out embodied energy.
So is that
Because there's a carbon rating for all of those
Well,
types of
I-
things.
Why don't you just grow weed?
so you're going into like
What else?
up, so
Like,
that's
you know,
basically
like, you
so
guys
kind of think of the
play around with
form
like,
as
He's playing some real
going deeper
complicated
and deeper into the
Yeah,
tree,
so
into
this
the
part-
HTML tree.
Yeah,
This
this
part
is
is
how
how
to look for it. For the
Oh, wait, oh,
Like,
oh yeah, so say like, in the one inside this.
right, so if you know, okay, so you know, like someone's giving you a building,
inside
Cool.
you can start assigning times and sequencing to certain things.
And then the
Okay,
first
so-
one would be
Yeah, so like if you get a building from Salem, you can say, oh, that's gonna take 5 minutes. Like with this sequence. It's the same building, but it's been designed by a different person, same data structure.
every
You want the easiest
That's
one.
gonna take 3 minutes. Right, so you know, we're just thinking about data, no drawing certification, no, I know, you've learned, I think you've learned enough of yeah? Yeah, cool. That's all I'm here for, I'm here to make everyone, like, either if they've got a job, make their job as easy as, or if they don't have a job, then they get a job, right? So, by the way, this might be the future of construction. Like, if you think about it, if you've set up like an Excel file, Python script,
Literally write myself out.
no, you're
Like, I
writing
mean,
yourself into making
right,
money.
sorry.
Yeah.
Into a better. Oh, yeah. I
Right?
feel like I could get myself out of the.
Yes, totally.
Yeah.
That's all I'm here for. When I started at my I wasn't drawing for the details. That's what architects have to do, and they leave them agree. I was trying to funky room, like I want to give you guys the tools in play so that you can skip over some of those first shitty jobs that you have to do with scraps and
Well, actually,
shit.
that's actually zero, so I made it.
And you know, if you, here's the thing, if you know how to do the document control better,
So if I
teach
will
people,
link to your phone.
the first three are food.
and then suddenly,
Wait,
you're the person people go to. For
Yeah,
that.
so my one just does your
That's
first.
that's a good
It's like,
sign.
this
Like, if you're at Mervac or ACOM or, oh, you have a job, no, you have a job here.
Yeah.
You're gonna get a job at Apple.
You have a job. No, I got one from Asia.
Okay,
Yeah.
you're in Asia or you're at Mervac and you're the person who knows, like, distributes the information of how to do things better. It's nothing by the balls.
board games are the best. So, yeah.
That's it, we're done. So should we try that?
Worst thing about
Okay.
board games is you have
So-
to do this other.
Are we gonna have the same due date as well?
Of course,
Oh.
just look, this is an experimental part of an experimental course, right?
Yeah, you do it like
Like,
5
You know, they basically give me a pen and a laptop, like they give me creative control over what we're doing with it. And I go and try and teach people stuff.
Well,
right?
I won the
Oh,
stakes.
yeah, yeah, yeah.
And for some reason you guys have shown up because there's an elective and gave you the option to
No, I'm
bail.
pretty sure I won.
Like I,
Census data's
No,
passed.
no, I gave my, as in
I remember you crying.
I know, but.
No,
Oh,
you like
yeah.
broke down
Right
into
there.
and you had to
Make
make
the
the
basics.
face and stuff.
Oh, you can street too?
Yeah,
Oh,
yeah.
shoot.
That
Ugh, okay. No, I said to you, look, if you stay here, you went here. But
Yeah, do you
I told
actually
these
have any idea how to
ladies,
go about it?
they stay, then, you know, there's a lot of work to do. Yeah, we think so, yeah, we hopefully get some benefits out of that, and stuck around. So, what, okay, Most of the stuff's going
I think Carrie's doing the, Carrie,
Excel,
you're doing the full plan for
right? As long as I can get these guys to
You
put
do it
their
first then.
geometry and their data in a database that
What's,
then gives
So like,
you
have
a
this.
query
what's
I'll
the
put
function
it
in
in
Excel.
Now,
You.
Yeah.
Or you can use Google Sheets.
Oh, so I'll be analyzing it.
I mean, I've started just only.
But I want to
coding,
know
I don't
the-
code on my Mac.
Cool, okay, so, but you use Google Sheets or Excel or whatever, I feel like you could probably do all of that
What does
carbon,
the?
Or maybe I'll-
all the quantity surveying, possibly all your staging.
Maybe the facade.
Staging like-
Analyzing the facade.
I'm doing the
Complicated.
first person's doing facade.
In Excel, right? That's how you do it
Cool. Yeah.
normally, right?
Yeah.
Oh,
You've
no.
probably already got Excel files set up. But do you feel like you can just plug in into those Excel
Hey, I'll be
files?
proficient,
And
it'll
then
be a
what?
great floor plan.
Okay.
There will be
I
a
think it's
problem.
like,
I think
like
you have to reflect.
Yeah, so what we've got to do is we've got to look at
structures and
what
filings,
information you
like
want
pillars and
before,
filings.
how to structure that in a way so that it runs automatically.
Whole our jurisdiction.
Right? That either means we have to go outside of Excel and go Python,
And like, I'll have
pipe
like,
that information into
I think
Excel,
at
or
least
we could
two
probably
pools.
achieve it in Excel.
Try to get the pillars.
I've explained why we
working.
don't want to run.
Try to get the pillars and the firewalls working.
Yeah, cool. Why don't we want to use Visual Basic in Excel? Okay, so Excel is very, it has a coding environment in it
Oh, these are
that has access to all functions and scammers and hackers
Oh, okay.
will write Excel files just to do viruses
Yeah.
and then send it to people and goes, oh, we've written a shit
Yeah.
and then someone can okay and then hacks the computer.
so, well,
Government will not put projects to companies that allow those codes
Which
to
is
work.
like when I get home
So,
from work
and we all want to work for the government because that's where we get the most money. So, we got someone like
I need to go, like, before I come
government
here.
projects. As in Mirvac does
I'm
have a
on
project.
multiplex.
Sorry? Oh, sorry. Multiplex does have a project. So does AGL. So does Asian companies. Whatever. Right, they're all working for clients that are worried about their data. You know, if data centers are worried about this Reserve Bank, you know, super secret job. Not allowed to use BIM 360. You know, that's how
Games.
secure it needs to be. So that's why we can't learn how to do this only with Excel. We've got to maybe do some math.
properly.
So
Ages now.
Like, the place is.
first thing we should do, I think, is get some data queries happening and query the database at different stages with different files. So you've got a file that then represents revision A,
Mondays
and
and
then
Mondays
you've got
I
a file that
get
represents
the
revision B
Tuesday.
and C. Basically, just like tapping into the database. And then we can start trying to work out how to track the differences between the datasets. And that's definitely
I still did
part
pretty
of
good,
it.
but I didn't have to. Most people say it's mature.
I have no idea. So I've written 4D sequence animations for
I think I
buildings.
just, I didn't, there wasn't a portfolio option, there was
And
just
what
like
I've been told is, you know,
previous.
this particular element takes this
And I
name.
think I did that.
And this particular element cannot start being constructed unless this one is finished. And you kind of have to, it might be worth sort of drawing that out. And I can help you guys and start trying to turn that into code.
I still don't wanna do
But
it.
it's gonna be,
No, I
like,
didn't.
you've gotta
want to
in a way, understand
You
the
have to like.
algorithm of it all. So, but it's as simple as, you know, this takes this long, this can't start unless this happens.
What?
And then we can write
Language
something.
Yeah, language.
How do you do that? Yeah, but,
Oh, sorry.
no, yeah, but the Gantt chart is, I'm guessing something, your, can you make Excel just spit out, this is gonna take 5 minutes?
Like, what, oh yeah, because you do the 6 a.m.
Because
stop.
you could say, okay, here's the slab,
Fucking
and
hell.
while the slab's drying, can you start
It's so high.
or pour?
When you what's more?
It depends, but let's say with, with a particular method,
How did you get the job?
like I've done work for BlueScope, like trying to prove steel product is faster than the typical concrete construction. And so it's like,
Reverse 7 grade.
oh, you can build 3 floors at once, and then you can pour concrete on all of them. You can pour concrete all at the same time. But then you're on a building site, you've only got one concrete team, so they're going to pour one after the other. But you don't have to wait for that to dry. So there's all these weird little conditions that you gotta explain and think about. You've got to get them in code, either in Excel or either in Excel. The amount of time it takes and what the thing has to wait for, and then Python can then make that like sequencing. Let's just lay down the groundwork and we'll travel down the
Gym
path.
membership like
And
everyone else.
as long as you guys are learning, we might
So you're on the
get,
team for free, you go training for free.
and how come at the end, or we might get 50% of what we wanted. As long as I can see that you guys are learning stuff from this, then I'm happy.
He's like, hey, my name's Sailor. Thanks for tackling like me.
I have no idea what.
Man, that was a
Yes.
good part. You dislocated my jaw there.
Do you know what I mean? So for me, you expect you guys to be able to like hit a particular
I play rugby.
level is
How long was back in the day?
so that's why it's so easy for me to like make these fluid
I was,
forces around stuff.
do you still do a scrum? Do
Yeah.
you still do a
Yeah.
scrum?
So next week, what we do?
It's not contested, is it?
Oh, only.
If
I guess we
you could have an example
Like,
of
where like,
the
you actually
the
push.
Yeah.
things that
Oh,
we
you
discussed,
still contest?
how you would do them.
What?
That is a good
Oh,
sign.
okay.
Is that
Oh,
that's it all?
Like the scrums I used to do.
I definitely it's the whole process is like to
What's your favorite brand?
what that means is
And the worst part is
you've
how you have to put your
defined
hands
your inputs.
to like the scrum to get the ball out.
So I need a list of what these are and what the values are that are associated with them. Do you just want a fixed value of how much concrete the building has? Or do you want a list of
Or you want
what
to
the
clear them out?
what they're made of?
Do you want your seats?
So like here's a slab, so slab 1, it's
Sorry.
stupid number, it's 100 square meters of concrete.
IS250.
That's all you need. Is that all you need? Or do you also need, is that 100 square meters of reinforced concrete? Or is it 100 square meters of concrete reinforced with a screed? Like is that getting too deep?
Like
2000?
Like, can we just work with
Get Lexus.
a smaller choice of materials? Do you need do you guys need to define a table of the materials and their associated costs?
It's
Nitrogen, carbon rating.
Cruel.
So let's just start setting it up.
What do you want?
Your inputs need to be.
Yes.
You want a hatchback?
And what your outputs are. We can then make that agreement as those inputs are with the rest of the class and me. I'll give you guys default values and
Hatchback has more space.
I can
Is the hatchback
I
one
can
like you?
all the buildings that they're giving I can do this weekend.
I'm not very car
So
savvy.
I wouldn't worry about relying on the other students. I can do this.
Hatchback is the one
You might do the process.
Instead of the
Yeah.
tail comes out.
It's like the Toyota sedan.
That's
What I thought. There's only like the front 2 seats, isn't it?
I'm not marking you on that. I'm marking them on that. Yeah. Because they're all going to come up with the same answer. T.
I found out.
HDs for everyone.
Wait. I wasn't a part of that conversation. Do I still got HD? If you told me we were part of that conversation, you could have got HD.
You're not an engineer.
I was just explaining that I'm not marking you guys on this necessarily. this, I'm marking you on that. If I was marking you on this, then you could all just write T. And therefore, you're right. So HC's for everyone.
But like, how are you even marking us on this? Isn't this just the same for everyone?
Yes.
So I don't get it. So we're making a building in Grasshopper.
Yeah. But I'm going to change it. What? I get to decide the inputs.
So yeah, whatever.
Oh, so you're
design-
send us the script that we'll be working on.
Well, our design like matrix has to work on an input of geometry, which he did change.
How do we build? You know what? I'll look at what you said and then I'll ask questions.
I want you to make a building using scripts. I'm going to change the inputs for. Right? How many times have you written a script in previous classes to only get one outcome?
Yeah, so yeah.
Every single script you've written is probably just to get one outcome, right? You know, you've designed a.
We did one together.
Okay, good. So you designed a stadium roof with me, right?
Yeah.
How many roofs did you submit?
One.
Right. What did you do with Daniel or Christina in the previous class?
The last one we used Octopus to generate like multiple.
And which one did you pick?
I think everyone had to like submit 12.
Right, but one of them was the most optimum one, right?
I think so. Yeah. You had to highlight which one was optimal.
Yeah.
Building envelope.
And it was basically just the parameters stretching in and out, right?
Yeah.
It wasn't like 6 completely different shaped buildings, possibly.
Oh yeah, it was one shape.
Yeah. What did you do last term with Daniel?
Last
Oh,
term.
sorry,
That was last.
Yeah, that was Studio 4.
No, what's before you did the class with me?
Is
2, Studio 2.
Studio 2 is Christina, where we worked with NGOs.
Yeah, how many outcomes did you produce?
Oh, we grew
like
trees.
4. We were
We grew trees.
Oh, okay, but how many? You only need to produce like one design outcome, right?
No, we had 3.
Okay.
3 different sites, which we read and randomly placed shit on.
Right. Random's the critical word now, right?
Yeah, we can do that here.
Yeah, you're not doing it. And then,
Random columns, random
like,
windows.
but each of those was just a script that made a tree, right?
Yeah, and then
Huh?
it's randomly like
Literally
place
yesterday,
the trees
I was
on
with
the
the
site.
structural guy, and he was like, "We need to measure this because it's not matching up with the drawings that we had originally had. So we need to have building plans." Because like the columns were like not, they were like incorrect. Like so it was like okay, I guess
He's
it's
right, his colour's pink.
every single one was like different. It was like one was like 12 meters, and then the other one was like 1.5, and it's like a disaster.
I used to took our dimensions of an leading shape,
I'm like changing.
but they didn't care about that angle.
Change the
The
oil.
angle didn't matter much.
I do that.
Yeah.
Like, as in, if I take a rectangle structurally and I shift it to oblique, it's still trapped in the same distance.
Yeah.
And the forces might be a little bit different point.
You got scared.
What it meant was their structural model didn't line up with our
That's already too much.
Unless it's 5 dollars.
That's only
You know what?
Why did you draw the problem? So like, you don't know how.
Yeah.
They just didn't at all.
The other funny thing was, even though it was rectangularly oblique, if you took the center line of the oblique shape, parallel, there was a cylinder that came off of the oblique structure of that wasn't arched. If you slice through a cylinder at an angle, it's not it's an ellipse. And we knew that. We were okay with it being like a truncated shape. But they couldn't really work out where the truncation was meant to be, because they couldn't work out how to put the cylinder and slice it with the. So we had to do their structural documentation.
You can pay Andrew.
Thank you.
It's listed for like 16K. I've got rid of it. I got it down.
I need to find a group. I feel like Martin's okay. He should play. You guys can just be friends, right?
What happened?
I get these questions from Martin about like more advanced things, like Martin's already done it stuff last week.
It's like,
And I'm like, hey, you guys what he's doing.
my dad has like a 600,000 kilometer. It's also a taxi
Right,
car.
you're right. You've pretty much done. You
That's
finished
why
your
it's
results
so
last
very
week.
high.
Andrew, did you get the email from me?
Maybe.